Hello viewers, welcome you all for the lecture series on agrochemicals and pest control. In this episode, we will know about the topic agro-ecosystem analysis. The transformation of an ecosystem into an agro-ecosystem involves a number of significant changes. The system itself becomes more clearly defined, at least in terms of its biological and physico-chemical boundaries. These become sharper and less permeable, the linkages with other systems being limited and channeled. The system is also simplified by the elimination of much of the natural fauna and flora and by the loss of many natural physico-chemical processes. The health of a plant is determined by its environment. This environment includes abiotic factors, that is sun, rain, wind and soil nutrients, and biotic factors, that is pest, diseases and weeds. All these factors can play a role in the balance which exists between herbivore insects and other natural enemies. If we understand the whole system of interactions, we can use this knowledge to reduce the negative impact of pests and diseases. Decision making in integrated pest management requires a thorough analysis of the agro-ecosystem. Participants in integrated pest management training will have to learn how to observe the crop, how to analyze the field situation and how to make the proper decisions for their crop management. This process is called the agro-ecosystem analysis. Hence, in this episode, the following aspects are going to be seen. They are history of agro-ecosystem analysis, agro-ecosystem analysis methodology, agro-ecosystem properties and components of agro-ecosystem analysis, comparing ecosystem and agro-ecosystems, and socio-economic indicators of ecosystem health. Now, we shall move into the first aspect, history of agro-ecosystem analysis. Agro-ecosystem analysis originated in the late 1970s at the University of Chiang Mai in northern Thailand. At the time, interest in farming systems research was increasing, motivated by the realization that production per unit area was not the only constraint facing farmers in their pursuit of improved livelihood. To be adopted, new technologies needed to heed other constraints and therefore to emerge out of an analysis of the farm system as a whole. Agro-ecosystem analysis is a codification of the kinds of information that need to be gathered in order to generate technologies appropriate to different farming systems. It entails a broad and very often visual system analysis used to understand opportunities and constraints in an agro-ecosystem. Now, we shall move into the second aspect, agro-ecosystem analysis methodology. Go to the field in groups. Walk across the field and choose 10 plants randomly. Observe keenly each of these plants and record the observations. Plant. Observe the plant height, number of tillers, crop stage, deficiency symptoms, etc. For pest, observe and count the pest at different places on the plant. For defenders, Observe and count parasites and predators. For diseases, observe leaves and stems and identify any visible disease symptoms. For rats, count the number of plants affected by rats. For weeds, observe weeds in the field and their intensity. For water, observe the water situation of the field. For weather, observe the weather conditions. While walking in the field, manually collect insects in plastic bags. Use a sweep net to collect additional insects. Collect plant parts with disease symptoms. Find a shady place to sit as a group in a small circle for drawing and discussion. Kill the insects with chloroform on a piece of cotton. Each group will first identify the pest, defenders and diseases collected. Each group will then analyze the field situation and present their analysis in a drawing. Each drawing will show a plant or a hill representing the field situation, the weather condition, water level, disease symptoms, etc. will be shown in the drawing. Pest insects will be drawn on the left. Defenders will be drawn on the right. Write the number next to each of the insect. Indicate the plant part where the pest and defenders were found. Try to show the interactions between pest and defenders. Each group will discuss the situation and make a recommendation. A member of each group will now present their analysis in front of all the participants. Make sure that a different person will present each week. The facilitator will facilitate a discussion by asking guiding questions. The facilitator also makes sure that all the participants become actively involved in this process. Formulate a common conclusion. The whole group should support the discussion on what type of field management is required. Make sure that the required activities will be carried out. Keep the drawing for comparison in the following weeks. Now we shall move into the third aspect, agro-ecosystem properties and components of agro-ecosystem analysis. Firstly, agro-ecosystem properties. However, this complexity, at least in terms of its dynamic consequences, can be captured by 4 system properties, which altogether describe the essential behavior of agro-ecosystems. These are productivity, stability, sustainability and equitability. They are relatively easy to define, although not equally easy to measure. Productivity is the net increment in valued product per unit area of resources. It is commonly measured as annual yield or net income per hectare, or man-hour, or unit of energy or investment. Stability is the degree to which productivity remains constant in spite of normal small-scale fluctuations in environmental variables such as climate or in the economic conditions of the market. It is most conveniently measured by the reciprocal of the coefficient of variation in productivity. Sustainability can be defined as the ability of a system to maintain its productivity when subject to stress or perturbation. A stress is here defined as a regular, sometimes continuous, relatively small and predictably disturbance For example, the effect of growing soil salinity or indebtedness. A perturbation, by contrast, is an irregular, infrequent, relatively large and unpredictably disturbance, such as is caused by a rare drought or flood or a new pest. Unfortunately, measurement is difficult and can often only be done retrospectively. Lack of sustainability may be indicated by declining productivity, but equally, as experience suggests, collapse may come suddenly and without warning. Equitability is a measure of how evenly the productivity of the agro ecosystem is distributed among its human beneficiaries. The more equitable the system, the more evenly are the agricultural products, the food or the income or the resources shared among the population of the farm, village, region or nation. It can be represented by a statistical distribution or by a measure such as the Gini coefficient. Components of agro-ecosystem analysis. Agro-ecosystem analysis is an approach which can be gainfully employed by extension, functionaries and farmers to analyze field situation with regard to pest, defenders, soil conditions, plant health, the influence of climatic factors and their interrelationship for growing healthy crop. Such a critical analysis of the field situation will help in taking appropriate decision on management practices. The basic components of agro-ecosystem analysis are plant health at different stages, pest and defender population dynamics, soil conditions, climatic factors and farmers' past experiences. Now, we shall move into the fourth aspect, comparing ecosystems and agro-ecosystem. The developing sustainability in building a strong ecological foundation under the agro-ecosystem. This foundation then serves as the framework for producing the sustainable harvest needed by humans. In order to maintain sustainable harvest, though human management is a requirement, agro-ecosystems are not self-sustaining, but they rely on natural processes for maintenance of their productivity. Agro-ecosystem resemblance to natural ecosystem allows the system to be sustained in spite of the long-term human removal of biomass without large subsidies of non-renewable energy and without detrimental effects on the surrounding environment. Traditional agro-ecosystems most closely resemble natural ecosystem, since they most often are focused on the use of locally available and renewable resources, local use of agricultural products and the return of biomass to the farming system. Sustainable agro-ecosystems are very similar in many properties, but due to the probable focus on export of harvest to distinct markets, the need to purchase a significant part of their nutrients externally, and the much stronger impact of market systems on agro-ecosystem diversity and management. They are more dissimilar in others. Compared to conventional systems, sustainable agro-ecosystems have somewhat lower and more variable yields due to weather variations that occurs from year to year. Such reductions in yields can be more than offset from the perspective of sustainability through the advantages gained in reduced dependence on external inputs. More reliance on natural controls of pest and reduced negative impacts of farming activities of the farm. Now we shall move into the fifth aspect, socio-economic indicators of ecosystem health. Both socio-economic and biophysical indicators are required to monitor health of the agro ecosystems. The emphasis on socio-economic indicators here is not intended to diminish the importance of biophysical indicators, which are equally important in sustaining the health of the agro ecosystems. The socio-economic indicators proposed based on the following set of postulates regarding the health of managed ecosystems. Inherent conflicts exist between maximum short-run economic rewards of individuals and the long-run ecological well-being of society as a whole. Preservation, conservation and protection of the natural, ecological resources needed to support future generations require that the current generations make collective economic sacrifices. Investments needed to support future productivity must be made at the expense of current consumption. Collective human actions can ensure the long-run sustainability of managed ecosystem, whereas individual actions cannot. The action of each person individually has too little impact on regional, national and global ecosystems to ensure overall ecosystem health or sustainability. Thus, individuals must persuade others to work collectively to sustain or enhance the health of agro ecosystems. A set of basic human responsibilities eventually must be developed to ensure that collective human actions are consistent the long-run survival and health of the global ecosystem. Human responsibilities necessary for long-run sustainability include ensuring economic opportunity and social equity among people who differ with respect to gender, ethnicity, economic class, social status, nationality, geography, and ensuring equity in balancing the needs of those in the current generations with needs of those of generations to come. If human society fails to accept these responsibilities, we will not be willing to take the collective actions necessary for long-run sustainability. On the basis of these postulates, a basic set of generic socio-economic indicators of ecosystem health may be developed for managed ecosystems. Starting with the individual and moving to the global, socio-economic indicators of ecosystem health might include individual freedoms, including rights to live, thought, speech and action. Next is human health, including adequacy, availability and safety of food and water, clothing and shelter and remedial health care. Next is personal security, including incidents of physical abuse, criminal activity and violent crimes such as assault and murder. Next is self-esteem, including whether individuals are valued, nurtured and encouraged to achieve their full potential. Next is social acceptance, characterized by the absence of discrimination, affirmative actions to correct inequities and valuing of diversity. Next, economic opportunity, characterized by universal education, freedom of entry into occupation, ease of entry into economic enterprises. Next is social equity, characterized by effective families, strong communities, political freedom, valuing of diversity and nurturing institutions. In many cases, the generic criteria for managed ecosystems are sufficient to address concerns related specifically to the health of agro ecosystems. However, some cases more specific criteria may prove useful. Some socio-economic indicators of agro ecosystem health derived from the generic list are quantity, quality and cost of food or fiber produced, risk of degrading water quality, risk to human health and workers' safety, number of people productively employed, utilization of human abilities, rewards for human productivity, social dignity of the work, equity of opportunities with respect to gender, ethnicity, social status, etc., opportunities for individual ownership or scale negative or neutral, potential for strengthening families, potential for strengthening local communities, support of resource stewardship ethics or actions, and support of environment stewardship ethics or actions. The above list of criteria have not been validated by research nor they are intended to be inexclusive. The list simply illustrate that socio-economic indicators are associated with farming methods, farming systems, rural communities and higher levels of system aggregation and can be linked directly with the basic concepts of ecosystem health and sustainability. Some may question the wisdom of assessing agricultural sustainability for an individual field, farm, community or nation when sustainability ultimately must be achieved for the total of the society at the global level. One might logically conclude that production from a particular field is sustainable if the field is a part of a sustainable whole farm system. A farm is sustainable if it is a part of sustainable farming community, and a community is sustainable if it is a part of sustainable global society. If risk to sustainability arising at one level of aggregation can be countered at some higher level, the larger system will be sustainable, but the parts of natural ecosystems are not separable. Thus, the complete nullification of ecosystems risk may not be possible. The human body is a system. The basic function of some body organs such as the liver and kidneys is to handle waste generated by other body functions. Other parts of the body such as the heart and the lungs may adjust their activity to accommodate stresses placed on other parts of the body. Generation of waste is a normal function of living and some level of stress is necessary for a human health. However, the body as a whole has definite limits to its ability to assimilate waste and absorb stress. When its critical limits are exceeded, an organ or the subsystem of the body begins to die. When a critical organ or the part of the body dies, the whole body dies. The system ceases to function. When agricultural production on a particular field is not autonomously sustainable, it places stress on the farming system as a whole. When a farm is not sustainable, it places stress on the community of which it is a part. A nation that is not sustainable places stress on global society. Some lack of autonomous sustainable should be considered necessary and normal in a healthy, interdependent society. However, the stresses the one element of society imposes on the society as a whole should be monitored and measured in the same sense that stresses on the body needs to be monitored and measured. In addition, it is no less important to measure the social and economic stresses an agricultural system places on society than to measure the physical and biological stresses that agricultural plays on the natural ecosystem. Excessive social or economic stress are no less a threat than an excessive biological or physical stress to the long run sustainability of an agro ecosystem. Now, we shall conclude this episode. Agro ecosystem assessment will merit the attention of agricultural practitioners when it can relate the system properties of agro ecosystem production to agro ecosystem structure in a simple and comprehensive terms. The foregoing discussion leads us to the encouraging conclusion that research on system properties of agro ecosystem structure should be able to develop guidelines for agro ecosystem design aimed at improving performance in a balanced fashion. Hope you all enjoyed this episode. We shall meet in the next episode. Until then, take care. Thank you.